Here we're going to examine Newton's third law of reaction and apply that to some sporting examples. In the exam, you're going to get asked to potentially define Newton's third law of motion and also apply it. So, for example, explain why Newton's third law of motion applies to, and they give you a sporting example, or apply Newton's third law to a sporting example of your choice. You need to be ready with one that you're really comfortable with and that you know inside out, or state which of Newton's laws is applicable in this specific example. So we're going to start off with the definition. N3 reaction. For every action force applied to a body, there's an equal and opposite reaction force. I think this is the easiest. This is the easiest one of Newton's laws to explain. So the netballer, and really, the key is equal and opposite. And we need to be specific about opposite in order to get our marks. So the netballer applies a downwards force into the ground. So downwards action force into the ground, and the ground applies an equal and opposite reaction force upwards on the netballer. So whatever one body exerts a force on a second, the second body exerts that exact force back on the first. This is the real explanation of how a person is able to leave the floor to jump. So netball applies a downward action force into the ground, and the ground applies an equal and opposite reaction force upwards on the netball. This is a takeoff for this jump. If the action force is greater than weight, the player is able to jump upwards. And that action force greater than weight is generated through those eccentric muscle contractions as you bend your knees and flex at the hips at takeoff, and the downward swinging of the arms. Again, with the hockey, we're going to start with the definition. N3 reaction. For every action force applied to a body, there's an equal and opposite reaction force. So here we've got the stick and the ball. They're the two bodies. They're each applying equal and opposite forces on each other. So the stick applies an action force forwards onto the ball. The ball applies an equal and opposite reaction force backwards onto the stick. Because the stick has the greatest inertia, that causes the ball to travel forwards. So if a hockey stick hits a hockey ball, the hockey ball has the smaller inertia, the hockey ball moves forwards. If I took that hockey stick and smacked it against a wall, same force, the wall wouldn't move forward, the stick would move backwards because the stick had the smallest inertia. Okay, N3 reaction. For every action force applied to a body, there's an equal and opposite reaction force. The sprinter applies an action force, and this time it's backwards, but I'm still going to talk about the direction. So the sprinter applies an action force backwards into the blocks. The blocks apply an equal and opposite reaction force forwards onto the sprinter, and that causes the sprinter to move away from the blocks. The football. N3 reaction. For every action force applied to a body, there's an equal and opposite reaction force. So the footballer applies an action force forwards onto the ball with their foot, and the ball applies an equal and opposite force backwards onto the player's foot. The ball applies an action force forwards, so that's sort of as the player. Here we're talking about as the player kicks the ball. Here we're talking about as that ball hits the net. So the ball applies an action force forwards onto the net. The net applies an equal and opposite force backwards onto the ball. Because the net has the greatest inertia, it causes the ball to stop. Obviously, the net's attached to those posts, giving it a large inertia. And finally, our golf example. For every action force applied to the body, there's an equal and opposite reaction force. So the golfer applies an action force forwards onto the ball with the club, and the ball applies an equal and opposite force backwards onto the club. So the trick really with Newton's third law is to think about the two bodies. When one body applies a force to the other in one direction, the other body applies its force backwards onto the first body in the opposite direction. And reaction is as simple as that.